I'm David Conwell, and I'll be also speaking about the barriers of thought identification technology.
Hi, my name is Vijay Krishna. I'm going to speak about the implications in this technology.
Good evening, everyone, and I'm going to start the presentation. Our topic is thought identification, and I'm going to present you about the past technology which was used in this thought identification process. The past technology that has been used is the polygraph. The polygraph is nothing but it can be referred as a lie detector. We have seen many scenarios where people use this lie detector to find out the truth and everything. Basically, this works when the people record their physical actions of a human being, like the blood pressure, the respiration, the flow of the skin and everything that is related to a human, in order to capture all the reactions and to detect whether he's speaking truth or he is lying on some issue or something. The basic idea of this polygraph is that when you test a person, first the person who is testing the person will ask him about 2 to 3 questions simultaneously, so that he'll record every pulse and every activity the person's the body is undergoing, and he'll record it through a graph. You can see that we have the monitor and the graph is presented there. After the recording is done, based on those questions, he'll analyze if he's telling the truth or no. Why? Because if the blood pressure is up and down, or if he hesitates in something, it might be detected as a lie. After collaborating the genuine questions he has asked, then only it can be recorded. In this, there is a defect, like the person who has a fear symptom, if he's telling the truth or false, he might be in a fear, and that recording cannot be captured correctly because of the fluctuations in his like blood pressure or the skin and everything. So sometimes it might be a failure. So there are many advanced technologies which have been implemented by reducing this effect in this polygraph. Like most of the scientists in the past technologies claim only 60% of it is as true, whereas other percentage, like person with fear symptoms and all, the information gathered is not correctly. So the further technologies will be explained by.
Yeah, hello everyone. I'll be talking about current technology. Yeah, basically the current technologies involved in this thought identification process. We have 2 classifications, the invasive and the non-invasive. The invasive typically talks about a process that implants sensors into the brain, and that requires that a surgical operation be done on the subject who is to undergo the thought identification process. But for our research, we would not be focusing on the invasive, because once a surgical operation is done and you have the sensor implanted in the brain, it means that there are several limitations, because it has been said that if one is thinking about a particular object, your experience of that particular object differs from my own experience of that particular object. Probably, I might have a hammer with me, in which I used to nail something, and somebody might have a bad experience with that hammer. So if we do the invasive technology, it's going to be at a disadvantage, because once it's implanted in a particular part of the brain, we can't change it to the other one. If we have to do that, that person has to go through another surgical operation again, and that could be quite damaging. So we'll concentrate on the non-invasive, which typically measures brain activity with external sensors. You can see that picture there having like several electronics and stuff like that, on the scalp of that particular person. So basically, we'll just talk about two widely used non-invasive current technology. That's the functional magnetic resonance imaging, the Fmri, and the EEG, the electroencephalography. The fMRI actually maps a brain pattern that corresponds to families of words. So now what scientists, what researchers have been able to do is that for us to actually know what is going through your mind, you go through the MRI scanner and stuff like that, and you are presented, before you go in, you are presented with several kinds of objects, words, and stuff like that. And at the end of it, it helps in actually putting together, categorizing the different kind of objects that you must have seen. For example, maybe someone who is seeing a table, chair, and stuff like that. He put it in the category of furniture. So the person does not necessarily have to see everything that relates to furniture. Probably, you've only seen table for the whole lifespan of your life, and if you are presented with something else other than table, it will be able to detect that, okay, this is what this person is actually thinking, because it can actually categorize it under different categories. Also, under the fMRI, we have this the spatial pattern that actually help in detecting what your responses could be even before you give the answer. Probably someone is asking you a question, and even before you verbalize it out, it helps to actually help us know what you're thinking prior to the answer that you're giving, and also we could know if you're actually lying or not. Then also scientists actually use what we call the Bayesian model to be able to read the thoughts of human beings. The Bayesian model actually have two forms, the formal model and the a priori model. The formal model actually talks about the images that are formed. For example, when you are looking at, as I'm looking at everyone, there are some kind of images that have been formed in my brain such that even if I've not seen, like, okay, let me put it this way. We have some Indians here. We have Americans. We have probably Arabs and stuff like that. So if I walk out of this class, probably there's a flash of these people on my face. Then I walk out of this class. If I see a group of people, like multitude of people, I will be able to categorize, okay, which people among these people are Indians, probably because of the few seconds of flashes of Indian people that I've seen, and probably Americans and other nationals there. Then the last one I'll be talking about is the EEG, which uses the electrodes placed directly on the scalp to measure the brain activity. And the recent research, I think that was 2013, last year, they were able to actually develop a brain-controlled wheelchair in which someone with a disability could move that wheelchair with a thought pattern that is going on in his mind. If he sits on the wheelchair and he wants the wheelchair to go right, he could actually just have a thought of it in his mind. He doesn't have to say it out. He doesn't have to press any button. All he has to think is, I want to go left in his mind. Then the wheelchair goes left. If he wants to go forward, backward, and stuff like that. Then David will be talking about the barriers to this technology. Thank you.
Hi, I'll be talking about the barriers, basically, from what was Polygraph, MRI, and then what will stop us from basically becoming science fiction. I'll start with actually just the barriers for each individual type, the intrusive, the fMRI, and the EEG. For the intrusive barriers, you have to think, in what language does the brain really speak? Does it speak in Java? Does it speak in C++? Do you treat it like a computer? It is your organic computer. So how do you interface with something that you don't know the language of? I think everybody's had a problem with Mac and PC and trying to get files from one to the other. Now imagine if one's just completely different. Imagine one's just a pile of goo, basically. Now, how do you hook up your USB drive to that? The second one is actually a little more philosophical, the fMRI. Each brain is a sum of its individual interactions, events, experiences. So, like Akunle said earlier about people's interactions with a hammer. Let's say a chef's memory of a knife or their initial response, their perception, would be far different than someone who had recently been attacked by a knife. So while one might be a professional, one might be a traumatic experience. Or the situation, let's say an urban dweller who doesn't own a car, basically takes the subway everywhere, will have a completely different interaction with a car than someone who uses one on a day-to-day commute. So if you have to actually tailor each individual thought process or thought reading to one particular person, then it doesn't really make as much sense. Here's a pretty good indicator. So it basically breaks up, let's say you view an item like celery, it breaks it up into a couple of different indicators. So you see the section there, it says eat, taste, fill. Well, the difference between, you might be able to tell the difference between if somebody likes celery or doesn't like celery, but you probably can't tell why they don't like celery. Maybe they had food poisoning when they ate a lot of celery. Maybe they, who knows? Maybe they're allergic to it. But you wouldn't be able to tell that really without almost an autobiographical interview with them. But if you're trying to read their thoughts, why not just take the autobiographical interview? So basically, they'd need to be calibrated. So this would take hours and days, maybe even weeks, inside an fMRI, asking them comprehensive questions about how do you feel about celery? Why don't you feel this way about celery? And on and on and on. And if you know anything about these fMRIs, they cost over $1 million, and they take up a whole heck of a lot of energy. So then on to the EEG. This is just that skull cap that we saw earlier. The problem with that is it's a high signal-to-noise ratio. You can kind of get it to go forward, backward, really not that much other than that. You can kind of detect which way it wants to go, but really not as much. It's pretty similar with the intrusive, but with less accuracy because you can't pinpoint and really reduce that noise. And then on here to the implications.
Hi. The implications of this technology. In Japan, the research have been made a gadget that allows to take the direct pictures into the screens, direct pictures from the brain. And also we are, before we talking about fMRI and EEG, we have a lot of connections are required to read a mind. They are planning to make a gadgets with a single connection with the brain to read the images of the brain. And some of the advantages through this technology, recording the thoughts processed through a single chip set instead of Polygraph, fMRI and EEG. We can use this technology because we have before we using fMRI and EEGs, we require a lot of connections to read the brain activities. But they are going to they are planning to implement a single connection device to read the images of the brain. And one more advantage is possibly it is very easy to identify the theft before it going to be committed, if you have access to read the brains of the criminals. And a group of Japanese effectively shows that the straightforward pictures delivered from the brain to the computer screen. They are not the signals, they are the pictures of the what they are thinking. And some of the cons, and by using this technology we have some defects also. Loss of privacy. Every individual wants to keep some of the information in their brain, some of the important information. If you have anyone have access to their brain, they may lose their privacy. Like if someone have someone have someone have access to your brain, they may get their passwords, our passwords and PIN numbers, etc. Thank you.
Very good. Anything else? Anything else? Any questions? Any questions for group, the first group? Any questions? Loss of privacy. Your thoughts. Penny for your thought. Any questions? I have a question, quick question. Did you read anything about when do you think this will happen? We saw a video 5 years ago and they updated it last year, didn't say much. Where do they stand now? You read anything about where they are?
Unfortunately, a lot of the organizations that are doing research on this tend to be fairly secretive or government organizations. So oftentimes research won't be publishable or openly available. There are companies saying that they can do targeted marketing and read whether someone will like this or that, but I don't think the science is quite there yet. I think they've made some improvements, but I don't think it's the level that it should be or that it could be.
I have another yes.
Yeah, well, I also think research is still ongoing in this field, and some researchers are kind of confident that probably within the next 3 or 5 years, we should have something much more better, in accuracy, something that is more sophisticated than what we have now. But it's a whole lot of work, so let's hope that it does actually work.
Another question. Yes.
What's the possibility of like perfecting the technology to a point where you can, so you talked about reading someone's thoughts, what about actually forcing thoughts onto the subject? Did anyone come across anything speculating about that?
Did you want to try and... the only information I saw is basically the brain is very, very good at taking input, even if they're artificial sensors. Whether you can actually authentically put that memory or that feeling, that emotion into somebody, they really don't know. I think they're more interested in trying to get something out first, and then they'd have to think about it. But nothing in particular now.
One more question, if I may. Sign language in every language is different, I guess, right? Correct me if I'm wrong. So Chinese sign language is different than Arabic than English, I guess. I don't know. How about, heart in English has another word in Arabic, another word in Indian, another in Chinese, and so forth. How do they have the same MRI talking about the heart, for example? Do they have the same part of the brain, or?
Yeah, I think when you think about a word, probably it doesn't matter which what language. I think is the image that matters. If I think of heart in my own local dialect, I have a mental picture of what a heart looks like. If you're thinking about it in your language as well, you have the mental picture of what that is. So
okay, let's give them a hand, please.